All right, start with your questions. Yes, what's the question? Which slide? Okay, which topic? Program correctness. Okay, sure. If I go to program correctness, okay, and then, and which 10? Page 10, okay. Okay, what about it? You know what? Maybe make sure you download the latest slides because, you know, always on the course website, I always say, when was the last updates? So I guess you just download maybe the second latest. Yeah, just make sure you download the latest one. Yeah. Your question was about this notation over here?
Yes, you said you don't have, well,
I would say you may choose to write B0 when you have to, but sometimes you may not have to. For example, in this case over here, you can see this is in the case of the precondition, right? In which case, you don't really have to say B0. You don't have to, even though you can say that. In this case, every variable in here will be in the pre-states.
can I write B0 is greater than A0?
Yes, you can do that if you want to. So here, of course, there are many ways you can write this. The simplest way is simply to say B larger than A. It's simply equivalent to B0 larger than A0, right? Yeah.
And in the post condition,
Yeah.
for the A, since it's not changed in the program, could it be A or A0?
Okay, so here, how you actually specify the post condition is not relevant to how you implement the body of the code. It's not relevant, okay? So now if you look at the post condition over here, you can see the only 0 value we have is B0. It's as if you say old B. That means you want to say the new value for B is equal to the old value for B minus the new value for A, right?
How come we don't write A0?
Huh?
How come we don't write exactly?
Well, I'm just saying for this particular example, if you write your in the post condition, you can refer to either the pre-state or post states, right? So you got to be very careful what you write on the post condition. If you choose to write, for example, A over here, that means you really mean the post state value for A. If you write A0 over here, it means something completely different.
Right. So would this post condition be correct? B0 minus A0?
B0 minus A0? Okay, so rather than, so what we can do is, what we should do is you formulate this. Let me just put it on the iPad and then we'll switch. You are basically asking, so the precondition is the same, right? Let me just say B larger than A, okay? And then B is assigned to B, yeah, I will switch. I'm just copying, don't worry, I'll switch. So now what do you want the post condition to be?
B equals B0
Okay, sure. In this case over here, okay, I see what you mean. Okay, so now let's just calculate, okay? Guys, are you able to prove if this core triple here is true or not? Are you able to do it? How do you calculate? How do you prove? How many steps do you need, according to what we said in the lecture? So now I'm asking whether this whole triple over here is true or false, right? Can it be proved true? So now, what should you do first? Calculate what? All right, so I want to calculate WP over here. B is assigned to B minus A, and then B equals B0 minus A0 over here, right? That's what you have, okay? Now, we know that in order to calculate this, which rule should we apply for WP? Assignment, right? So you can say WP rule for assignments over here. So what I would do is I'm going to replace every occurrence of B, not B0, okay? So that means what I would do is, conceptually, you have to replace every occurrence of B, which is only here. Replace that by B minus A, right? So what you would get is B will be replaced by B minus A is equal to B0 minus A0. Okay? Now, anything we can simplify? Anything we can simplify over here? A, okay, now that in this particular case, what you can do is you can see that the implementation over here, as you said before, it is not trying to modify A at all. So now what you can say is the implementation for the whole triple over here does not modify A. So that means A and A0 is simply just the same. Agree? If they are simply the same, we can cancel them out. So that means this will boil down into B is equal to B0. Okay? Okay, any questions? Yes.
You said we change to B minus A, right?
Yes, correct.
So every B would be minus A.
Correct.
So
In the post condition, right?
Yeah, shouldn't you have like B0 minus A and then minus
No, no, no. Okay. So when we say replace, right? So you can see that over here. Notice one thing over here. If you look at the post condition over here, you got B here and B0 over here, right? You can think about them even though they refer to the same variable, but they refer to the same variable at two different states. B0 is in the pre-states, and B is in the post states. So when you do the replacement, you should really be careful. You don't replace them both at the same time. Okay, so now when you want to do the replacement, you're saying that over here, what I would say is over here, B is assigned to B minus A, right? That means the value for the post states will be replaced by that. That's what you do.
But I thought that maybe like there should be three. So B0 minus A0, for example, minus A. This is what I...
You're right. That's something I just didn't mention. Okay. Now let me say one more thing. That's good. So now if you look at B is assigned to B minus A, right? Just look at that. Okay, if you look at this particular assignment over here, right? Now, if you look at B is assigned to B minus A, when we say B over here, which B are we talking about? Are we talking about B0 or B? Well, in the pre-state or post-states, in this case, the B here. In the pre-state, right? Because you're saying that I'm just going to say B is assigned to B's initial value, right? So this is as if we said B0. But usually in the implementation, we don't really say that, B0, but you had to judge by yourself. Okay? So now, what I should have done was, so when I say WP rule for assignments over here, right? Let me just make it more precise over here. I'm going to say replace each occurrence of, in this case, B, right? It's on the left-hand side, of B by, and now in this case, B minus A. We know that B over here means B0. Agree? By B0. Okay, so that means this should be B0 instead. That's something I didn't really do right in the first time. Okay, so now, if you got B0 over here, you got B0 over here, so what does that mean? That means you can also cancel that out, right? And also A and A0 is also the same, so we can also cancel them out. So what you have over here, B is equal to B0. Okay, just get rid of it. So that will be just true. So now true is the weakest precondition. And what's the next step? Okay. So now if we go back to the original slides, let's remind ourselves what the precondition is. If you look at that, it's simply B0 larger than A, right? Okay, let me just copy that here. So now, second step, we're just asking ourselves this question. B0 larger than A, the original precondition, does that imply true? Does that? Wow, you better answer that, right? I know the answer, but it's not very useful to you. You better tell me whether you think that should be the case or not. Huh? I heard trivially true. Okay, anybody else? Okay, I heard another answer, depends on the value for A. Okay. Even if it's false, right? Okay, we're moving somewhere. Okay, again, review session is your time. Try to, think aloud. That's okay, right? It's a little bit different from the lecture. Okay. Anyway, you're basically asking, let's say you said depends on the value, right? Depends on the value for B0 and A. You say it could be true, could be, sorry, false, right? Let's say B0 happened to be 3, let's say, happened to be. And A happened to be, let's say, 2. 3 larger than 2 will give us false that you just suggested. Now, false implies true would be? Oh, yeah, sorry. Good. Okay, so you're awake, that's good. 2 and 3, that's what I meant, okay? 2 larger than 3 will give you false. False implies true, give you true, right? Okay, now let's try another possibility, right? It's a Boolean expression, so it can be either true or false. What about we try what I got wrong before? What about 3 and 2 in this case, right? That means it will be true implies true, which will be also true. So it seems like it doesn't really matter what this expression is, right? So that's why you said this will be trivially true. In fact, we did mention that in the class to say true is so-called the weakest predicates, right? Weakest predicates that you can ever get. Which means if this true happens to be the weakest precondition, then that means you can put any precondition you like, including false. Okay. You mean which one? You mean here? Oh yeah, of course. I'm just talking about truth table, right? Yeah. Hmm? Yeah, correct. If you okay, again, if you remind yourself, let me do that here. If you remind yourself the truth table, right? Let's say P and Q, and then true, 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 false, false, true, false, false. And then you got P implies Q. Basically, first of all, we know that as long if the antecedent happens to be false, we know that this part here is guaranteed to be true. Doesn't matter what the Q is, right? And then if the P happens to be true, and now if Q is also true, that's good. You can still be true. However, in this case, if antecedent is actually true, but the Q, consequence is false, that will give you false, right? Yeah. I believe I talked something about this, maybe about binding the contracts. You know, in the first lecture, you can review that. Okay? But just a truth table that you should be familiar with. Okay, next. Yeah, basically, don't lose the big picture, right? It's a very contrived example. The lesson to learn from this particular example is whenever you try to do the replacement for the assignment rule for WP, you have to make sure you got to replace the previous value by denoting 0, right? That's basically what we have been doing. Okay? Yeah. Okay, next questions. So should I say only wait for 1 minute? No question, then we call it a day. I'll give you guys some pressure, right? Yeah. I know everybody is busy. I'm busy too. But you know, since I allocated time for you, just use up the time. Yeah. For what? For class. Yeah. You're talking about inheritance? Okay, I'm not exactly sure what your question is. Let's try to work it out, okay? Okay, let's say you're saying that we have one class, deferred, you said? Okay, let's say A is deferred, sure? Sure, okay. As a new method, sure. Let's say, what about we call it feature F, F2, for example, okay? Okay, so you're saying that, let's say for F2, it does not exist in A. Okay, so let's say this, depends. Oh. You should have reminded me earlier, okay. All right, we got A and B, A is deferred, and also we got B, right? Okay, so now, one scenario can be, if I say A, let me just give you a simplest case. If I say B and then B, oh, actually, I shouldn't give you Java, right? Let's say we got some local variable declaration over here. Let's say B is of type, static type B, okay? And then over here, we can say creates, and then we can say dynamic type is simply just B. And then we say B, okay? And then we say B dot F2. Should this compile or not? Yeah? It should. Why should it? Ah, good. Static type. I think that's what you meant. Okay? Yeah. This will compile because for B over here, if you want to judge for compilation, look at the static type, right? So B, we know that is static type. We know that static type you can see from the declaration here, right? It's B. Does B define this particular feature F2? Yes, it does. Okay, so this should compile. Okay, that's scenario number one. Okay, my guess is maybe the one you talk about not compiling is like this. Okay, let's say I got, let's say A over here, okay, of type A. All right, and now let me put something like that. I say creates dynamic type. I will still put B. Okay, and then I would say A. First of all, does this compile? The blue line. Does it compile? Anybody else? Does it compile? It compiles? Why? B is a subclass of A. Okay, you want to be more complete, right? Basically, you can see B is the dynamic type that we want to assign to A, right? And B is a descendant class of the static type of A, which is over here, right? Okay, good. Now, so this compile. This one is okay, all right? So that means dynamically A is really pointing to a B objects, all right? Good. Now let's try further. What we can do is, let's put another blue line. If I say A dot F2, would it compile? It seems to be compilable because A is really pointing to a B object, and B is really defining F2. It seems to me it will compile, but would it? I heard no, okay? What static type? You mean A static type is A? Aha, good. I'm happy, good. Right, let's have a look. A here, doesn't matter what the dynamic type is. We know that the static type is A. And A does not define F2, right? So that means this does not compile. However, it's really pointing to a B object dynamically. How can we get around with this? A cast, all right? You can do a cast. Yeah, you want? Let me finish the cast and then we'll take your question, okay? So now how do we do a cast? I'll do the cast quickly, okay? As we learn, you're gonna say something like, yeah, something like that, yeah. Check, and, oh, attached. Attached, and then cast to B, and then A, and then S, maybe some B object, I'll say bow over here. And then what we can do is we can say B objects dot F2, right? This will be okay now, all right? Okay, it's a nice question, but make sure you understand that, all right? Again, I would say this kind of knowledge is not just important for the exam. It's actually quite important when you go out to industry, right? You should really understand polymorphism and dynamic binding pretty well, right? Yeah. All right. How many of you will actually go for co-op after this semester? Not many of you. What about in the summer? Ah, okay. Yeah, so you really got to get prepared for that, right? Yeah. Yeah, next question. Oh, you got a question, right? Just ask, that's fine. Creates? You mean the create over here? Which create? You mean, for example, are you talking about the create over here? No, it's like a new in Java. It's not really like a cast. You're just creating a new object, right? Next question.
Like a question, but would you be able to summarize visitor pattern? Like,
Summarize depends on how brief you want the summarization to be.
not really, really brief, but
Visitor pattern, okay? Okay, let me sketch, all right? Visitor pattern, okay. You know what? I'll rather do this properly, you know? Oh, okay, I can still summarize, it's not a problem. Okay, what I would do is, you can see the slides, right? What I would do is, I will, first of all, I will go to the visitor pattern. Okay, visitor is over here. I will go to the architecture diagram. For what? What do you mean undo redo is a better example for visitor? Uh-huh. But you know, it's a different pattern, right? So it doesn't really, okay, let's see if I can just get it easily. There we go. All right, good. Now, how do we summarize it? Okay, how about we do it together? Yeah, it would be quite boring if I just keep talking, right? Okay, now, quite many things you can learn. Okay, we talk about open-close principle, right? Open-close principle. First of all, what's really open-close principle? Anyone?
you want something hidden from the line. Like it's basically when you want to close something, and so it's going to be hidden from the client.
True. What about open part?
Open is going to be like flexible, so you can actually extend it.
Extend. Okay, good. Basically, open-close principle over here is for the part that you decide to be open, so that part of the system, for the part you decide to be open, that part of the system should be acceptable for extension. On the other hand, for the closed part, whenever there's any extension, you shouldn't go there. Okay, that's good. That's very brief. Yeah. Now, in the case of the visitor pattern, okay, let's go a little bit backwards. Okay, this is a visitor pattern. Apparently, we got two parts of the system. One part is about the language for the expression. Okay, yeah, it's about expression language. And this part here is about the operation for the language, right? Which part is open, which part is closed? Okay, which part is open, first of all? Operation, good. This part is open, okay? We'll see exactly in just a moment, okay? And then this part is closed. So now, let's say, if I chose the opposite, okay? I chose the opposite. I'm going to tell you right in the beginning, what I'm going to demonstrate is this particular case where I choose this part to be, okay, let's say this. All right, let's say I choose this part to be, let's say, closed. That's what I meant. If I chose this part to be closed, this part to be open. Now, the fact that I actually decided this part should be open and this part should be closed, that does satisfy the open-close principle because I make a decision. So that one's satisfied. However, the consequence of this is going to violate the single choice principle, right? So you want to make sure both are satisfied. Okay, now let's go further. Why would this violate the single choice principle?
Here there's a constant.
Okay, let me make it easier for you. Okay, yeah.
And also like there is let's say like we want to add more for the printer and the stuff.
Okay.
We want to, so we cannot.
Okay, let's say this. So now, the fact that we say one part should be open, the other part should be closed, okay? Doesn't matter how good or bad the judgment is, as long as you make a decision. That satisfies the open-close principle, right? So now, I'm claiming that this satisfies open-close principle, but violates single choice principle, right? Single choice. Now, we want to see why this will violate the single choice principle. So the way it violates the single choice principle is when we try to make an extension, since we decided that this part will be open, even though it's a wrong decision, but let's try, just go with the wrong decision and see what happened, okay? If this part is open, that means we can extend this part. So what does it really mean to extend this part? This part is about expression language, so we can add some new construct, right? Let's say we try to add a new construct, for example. Let's say I want to add, currently I got constant, I got addition, right? Let's say I want to add multiplication, for example, right? So what I would do is I'm going to add a new class over here, in here, okay? I will call that M for multiplication. And of course, multiplication, like addition, is a composite operation, right? It should be a subclass over here. It should be a subclass over here, right? And of course, it's going to inherit this particular defer feature here. That's going to be accept, right? I'm going to implement that, right? And then it will take a V and then visitor. What else do I have to change? Yes. Yeah, right? So somehow, you see, it will require me to actually modify the close part. That's not so good, right? So now, not only that, if I have to modify the close part, so now how many classes do I have to modify? All of them? Okay. How would I have to modify this class, for example? What should I do? Huh? Add a new method? Okay. Or what should be the name of the method? Visit. Huh? Yeah, let's be precise. Okay. So now tell me exactly what I have to add to visitor class, which is deferred. Visit. Visit what? Visit multiplication, right? In this case, right? Because you can see the visit over here, pay attention to detail. Over here is really important, right? Because IFO does not support overloading, so you cannot have feature with the same name, okay? You're gonna say visit multiplication, and then what should be the type of the parameters over here? Multiply? Okay, same as this, right? Yeah, I just call it M, right? So now say over here, I would say multiplication of type M. That's the first change. So now, do I have to change anything else? Apparently this should be defer, right? Anything else I have to change? Exactly. So that means this will be inherited to every one of them. So that means I can multiply every one of them as well. So I'm going to define visit multiplication and something here, and visit multiplication over here, and also visit multiplication over here, right? So there are multiple places I have to modify for this particular new change, right? So that violates the single choice principle, right? All right.
So maybe there will be like a question like this. So would it?
Yeah.
With the principle open close,
Yeah.
then I would say yes, but it was.
I will put it more general. Basically, you have to understand for every pattern we cover in the class, for each pattern there, what's the context for applying them, and what kind of principle you have to watch out for each pattern. For example, for the visit pattern, you have to know open close principle. And if you actually satisfy the open close principle in this way, but somehow you chose the open part to be the wrong part, that will actually violate the single choice principle, right? Something like that. Yeah. So now, what you have to know, which I assume you will know. So we know that if we make such commitments over here, that means this decision is not good in case you want to add a new expression language, right? So now what we should do is we can backtrack. So now, what happens if I say, rather than choosing this part to be open, let's say this part is closed, which means we don't add any more new construct for the language. And this part should be open, let's say. If we do that, in that case, now if we want to add just a new new expression language like a multiply, are we gonna violate the single choice principle? Julian, yes or no?
If it's the opposite way, we got a class for the operation cluster.
Yeah, exactly, right? So that's something you want to go, yeah. Let me say it again. So now in this case, because now if we choose this part to be closed and this part to be open, that means this part should be open for extension. Let's try, okay? If you want to add a new operation over here, let's say, for example, I want to add something just over here to be, let's say, generator, right? You want to generate some code over here. So generator, like a generator. And over here is this, what should we add over here? Yeah, effective feature, right? Basically, everything that you define in the visitor class, you have to add them up, right? You're going to add them over here, add them over here, add them over here. And that's a single class you have to modify. So that satisfies the single choice principle, right? Yeah. All right. Hopefully that's a reasonable summary for you. Okay, one more thing to remind you about, okay? For visitor pattern, for this one, I encourage you to study for that, and then maybe come back tomorrow if you can make it, for the question. I think you really have to understand very thoroughly. At the runtime, okay, there's something called double dispatch. Okay. And you're going to review exactly how double dispatch will happen at the runtime. You have heard about this, right? Previously, right? Yeah, just make sure you know the details. Yeah. Yeah, basically, if you study for each pattern, you should know what's the really unique feature about each pattern. For visitor, of course, double dispatch is one of them. Yeah. Yeah.
Is it always the case that at the time when you were the function?
Is it always the case? Oh, sorry, I didn't really hear the question carefully.
In this case, open is on the side of the visitor.
Oh yeah, for the visitor, yeah. Exactly. So for the visitor pattern, since we set up the classes in a particular way, like what's shown in the diagram, so the open part should always be the operation. Yes. Yeah. Yeah. Good. Okay, guys, questions? Yes.
Can we just go over the subcontracting?
Subcontracting, which part?
When we talk about what's not.
Okay, sure. Yeah, let me just see which part you would like to talk about. If I just go there, subcontracting. Is there a particular slide you would like to go over?
No, just in general with the required lesson.
Oh, sure, no problem. Okay, let's go over this one here, okay? This is the slide you had over here. What I can do is, let's see this. What I can do is something like this. Let's just talk about predicates in general, okay? If I got two predicates, let's say P and Q, okay? So now, again, P and Q, they're both predicates. For example, you can say maybe X larger than or equal to 2, and that's one predicate, right? And P and Q, since they are predicates, they might be used either for preconditions or postcondition, right? Okay, let's just talk about predicates in general. Let's not distinguish between pre and post condition just yet, okay? Now for P and Q, we say that P is stronger if P implies Q. Okay, one example would be, let's say P is X larger than or equal to 2. Then let's say Q is X is larger than or equal to 1. It's a very simple example, right? Now, why is that the case, right? Like a P implies Q. One way to think about it is, think about a set of values that will actually satisfy both predicate and see which one is smaller set, strictly smaller set, or equal or smaller set. In that case, that will be the stronger one. For example, if you think about, well, that's why you will see the expression like this. Let's say over here, right? It's kind of the expression you have. Okay, let me just go that way. So now, if I want to know all the sets that will satisfy P, basically all the sets such that P of X is going to be true, right? This will be the set, something like this, right? It's going to be the set which will contain P, and then there'll be 2, 3, 4, 5, 6, 7, and etc., right? Now, what about the set for Q? The set for Q over here is X larger than or equal to 1, right? So now, if we consider the set, let's say X such that P, not Q. Q of X is actually true, Now in this case, is it going to be a bigger set or a smaller set? Bigger set. So what? Plus 1, exactly. Yeah, yeah. So the way to draw it, something like this. I can put 1 here. Yeah. Of course, it's a very simple example, but that's how you judge, right? So now this is the set for Q, and this is the set for P conceptually, right? You can see the set for P is either equal to or smaller, so P is stronger. Stronger in the sense that the predicate it can actually ensuring more or require more. So the less value can be satisfied. Okay, that's about stronger and weaker, right? Good. Given that, let's say we try to compare the precondition and postcondition, okay? So now let's say for preconditions, okay, for the preconditions, let's say we got require and require. Let me just use the same example, okay? Basically, let's say this. Let's say P over here, X larger than or equal to 2. And Q over here, X larger than or equal to 1. Okay, we know already that P is stronger than Q. That's what we just said from the previous slide, right? So now let's go about for the require less or require more. So now, would you say P require more or Q require more? Require more in the sense that you will actually allow less values to be accepted for the input, right? Okay, so now what you can say is, you can say P over here require more than Q by not accepting the value 1, okay? Or you can say symmetrically the same, okay? I can say this require less. It's relative, require less than Q by allowing 1, right? Both are very symmetric. Okay, better? Okay, let's do the same exercise for ensure. Okay, we can still use P and Q because they're just predicates, right? So now let's do post conditions, okay? Now let's do post conditions over here. For post condition, we can say ensure, let's say again, P would be X larger than or equal to 2. I'll use the same predicate just for comparison. And also we got ensure over here, and then we say Q, X larger than or equal to 1. Again, P is stronger than Q. That one doesn't change. Okay, now, which one ensures more? Okay, ensures more in the sense that it has higher expectation on the output value. If the expectation is higher, intuitively less values produced by the supplier can be satisfied. Okay, so now what we can do is we can say that over here it would say ensure more. Ensure more than Q. Okay? By, you can say denying output value 1. Okay? On the other hand, you can also say that over here, this is ensuring less. Right? Ensuring less by accepting 1. Right? That's kind of the ensuring, yeah. And now, let's go to subcontracting, right? We got these two cases, right? So now, if you have, let's say, in the case of subcontracting, let me use maybe call it here, subcontracting. Okay, when we talk about subcontracting, we talk about if you want to define a pre and post condition in the case of subclasses, right? This is what we have to make sure, okay? What you have to make sure is two cases. In the case of the precondition, you want to make sure it requires less. Okay? In the case of post condition, you want to make sure it ensures more. It's something to do with the substitutability. So I will draw your attention to this particular diagram over here, right? If you think about it, so now let's say we have a feature over here, get reminders, that which we talk about, right? Get reminders. And that one there in the superclass, we got precondition and postconditions, right? So now the question really is, when we try to redefine the same feature in the subclass, right? So how can we constrain the pre and post condition in the subclasses, right? So now we're going to talk about require less, ensure more, okay? The require less part, okay? So let's say this. If I have something like this, if I have my phone, it's a smartphone, right? And now when I say my phone over here, dot, get reminders. Okay, if I just look at that, if I only look at this particular call over here, I know that the static type for my phone over here is smartphone. That means if I'm the client for this particular my phone, I should live up with all the expectation that's to do with the static type, which is smartphone in the superclass, right? That means if the smartphone itself tells me some precondition to satisfy over here, I want to make sure if I simply replace my phone, let's say this, if my phone was originally pointing to some objects over here, now, if I want to say now, rather than my phone pointing to here at the runtime, I want to substitute it into something like, let's say iPhone 6s Plus, right? Now say iPhone 6s Plus, the phone over here. Now, if I do the substitution, right, the client should not be shocked suddenly, right? If the client is trying to make this this method call again, they want to make sure whatever that's understood as a precondition in the parent class over there should be somehow maintained, right? In the subclass over here. Let's say, for example, if you just recall what we did before, right? Let's say over here. If you look at the get reminders in the superclass and also get reminders in the subclass over here, right? So now let's say this. If you look at battery level over here versus the battery level over here. Okay? Now, if you look at these two preconditions, are they appropriate or not? You think so? No. I heard no too. Yeah, try not to look at the answer at the bottom, right? Yeah. If you think it is okay, think about what's happening here, okay? If you think it is okay. Basically, what we are doing over here is like this, okay? Think about what I'm doing here. Let's say my phone over here is declared to be of type smartphone. Okay, we know the static type is simply the superclass, the parent class. And now, if I say creates, and then I'm going to create a dynamic type over here. iPhone 6s Plus. And then I'll say my phone over here. Okay, that's what I do. And then if I say my phone dot get reminders. Okay? And by the way, you can see that my phone at the moment is really pointing to a iPhone 6s Plus, right? Objects, right? It dynamically would require the battery level to be larger than or equal to 15%, right? Which means if that's 15, that's okay. You can still use it. If that's 16, you can use it. If that's 17, you can use it. If that's 18, you can also use it. However, what if the current battery level is 14, for example? Would it be okay? No. Okay, let me just write it down. We know that according to this contract over here, dynamically, it would not be okay. However, if you actually look at the static type, since we talk about my phone, if you look at the static type, is actually smartphone, right? In which case, the expectation tells us as long as it's larger than or equal to 10%, we should be all right. But dynamically tells us it is not okay. So there's a problem here. Because the dynamic instance, that's a subclass, requires more than what the parent class specifies as a contract, especially for preconditions. That's a problem.
So if
Yeah, exactly. So the principle is, if you look at the country, especially let's say for the preconditions, you want to make sure the precondition at the subclass requires less than the parent class. Julian, is that better? Okay, good. Okay, good. And symmetrically for the postcondition as well. Okay. Yes, you first, and then you. Yeah, fine.
Does it require else, like the program, like if the input passes one of the required statements, then it passes. So if it doesn't pass the
Yeah. So basically, you're talking about how the require is actually checked at the runtime, right? This is how it would be checked. No, it does matter. Because over here, yeah, you're right. So we'll talk about two things over here. Number one, we talk about design. When you design your contracts, yes, you have to make sure whatever you have over here require less than what's in the parent class. Number one, it's about design, no runtime. Okay, now second issue over here. At the runtime, somehow IFA will try to make sure it never happens stuff like this. Never happen at the runtime. Because IFA knows about this kind of issues in theory, so they will try to prevent this at the runtime. So how do they get around with that, right? The way they get around with that, I'll get to you. The way they get around with that is to say whatever condition you set over here, and whatever condition you set over here, we're going to say or at the runtime to check them. Okay, that's how you get around with this kind of a crash. But again, there are two separate issues over here. One is about design. To judge to see whether this is a good design, no, it's not. Okay? However, would you actually get to runtime assertion contract violation? No, because the way IFO check it will be using a disjunction operator, right? It's two issues here. Yes?
I was just going to say, runtime is checked more because the client doesn't expect to be shocked at the...
Exactly. So at the runtime, yeah, at the runtime, so what IFO will do is going to say whatever you specify over here or that one over here. So you're going to get true or false. You also get true. Yes. So again, we talk about two different issues here. One is about design. The other one is about how runtime IFO handles that. Two things. Yeah. Are you guys better? I hope. Yes. Oh, sorry, I forgot about you.
So is it, would it be safe to say that the child should always have stronger violence than the parent?
No, no, the opposite. The child class should always got something that's weaker for the preconditions. Yeah, but for the postcondition, the child should always get something that's stronger. Yeah. Yes. But of course, don't memorize that, right? Try to get into the reasoning. Yeah. Yep.
Is it okay also to do the same thing with visitor, but with the observer pattern?
Observer pattern, you mean to review it? Yeah, we can do that. Yeah, what's the question? Yeah. Do we mean, let's repeat the last part, I don't quite follow. I'm not too sure what you mean by bounds. When I say require less, I'm simply saying whatever input condition you have for the child class should not be stronger than what's required by the parent class. In some way, we are widening the boundary, right, for input values. On the other hand, for the output value for the post condition, we are narrowing down the output value because we're trying to ensure more. Right? There are two different directions over here. Right? Yeah. Observer pattern. Okay. For observer pattern, let's see what we have over there. For the observer, I will just go to. Okay, let me first of all go to all the slides. Observer over here. The observer pattern. You mean this one over here? Yeah. Okay, what about it? You gotta give me more specific questions, right? Yeah. Yeah, Julian, yes. Mm-hmm. As opposed to observer, yeah. Correct. 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 Yeah, you're exactly right. So observer itself is already much better than what we started with originally, which is over here, where we don't have the observer like this, right? That means every time when we want to update the app, we have to make an explicit connection to the server over here, even though it may not be necessary, right? That's the drawback for the first design. That's how we go to the observer pattern, where over here, the most important insight you want to get is every time when the subject has any updates, what they will do is they're simply just going to publish all the updates. Then they're going to call something a notify or publish. They'll call notify on every observer that is already subscribed in their observer list, right? That's kind of the other direction. Now, the reason that we want to move a little bit further to a third design was because if you look at the runtime, let me just go to the diagram over here. So this is basically complexity at the runtime. If you only got the observer pattern, you got more than one subjects for the weather data. Also, you got more than one applications, right? So they might be subscribed to each other. In that case, you got a very complicated runtime diagram. It's hard to manage. It'd be much easier if you try to reduce the complexity of this graph by doing something like this, right? So we introduce this intermediate events. So rather than having this particular weather data that is going to be responsible for all the updates for all the weather data, all the measures, let's say temperature, humidity, and pressure, right? These three measures. And what we're going to do is we're going to create one event for each measure. So one event for temperature, one event for humidity, and one event for humidity, right? And then we want to make sure every weather data subject is subscribed to this particular event. And also every application over here is also subscribed to this particular event. So you have some medium. Right? Yeah, you're right. Event-driven design is definitely better than observer. Yeah, I agree with you. But I would say event-driven design, depending on the language you're using, right? Let's say if you do that in Java, as I try to show you in the class, it's incredibly complicated, right? So I would say if you're pretty sure that you really don't have so many you don't have really so many objects over here, and so many observer objects here, you can still use observer pattern. Because after all, if you think about the complexity m times n, when m and n are reasonably small, you're still fine. But when they get to be very big, then you may want to think about moving to this particular design. So it's a judgment call, really. Yeah.
So what kind of questions we can get from the observer design?
What kind of what kind of lesson can we get?
Question
You can get any questions from observer pattern. Yeah. Yeah, so basically a lecture, right? So you have to know why we're doing this and also how we do it. And then if you do it, how does it work at a runtime, right? Yes?
So the update, when the observer notifies in the observer pattern, it's each observer is a list.
Yes.
Yeah.
Goes by index, exactly. So if you when you study the code, this is what you will see. For example, let's say over here, let's go to the subjects, right? If you go to the subjects over here, let me just go to, yeah. You can see that this is the class for subjects, right? You can see the feature called notify over here. The way we implement that is going to go across the observers, right? Which is a list of observer. And as I said before, observer is just a static type. Dynamically speaking, observer can be forecast, can be current conditions, statistics. It's a polymorphic collection, right? As we said. Good. So now, once you go across the observer one by one, for each one of them, you simply say cursor the item, which would be just an observer. And then we'll say the updates. Now, dynamic binding is going to work because depending on what's the dynamic instance for each observer, in the case where it's a forecast, we're going to update a particular field. In the case of a current condition, we'll update maybe only humidity and temperature, right? In the case of a statistics, we'll update all the things. Depends, right? So that's a notified. Yeah. Or let me just say one more thing before you take the next question. So if you look at the diagram again, this is what you can expect, for example. if you look at this diagram over here, right? Let's say we have an update for this particular subject over here. If it wants to do the notify, it has to follow the link for the first observer and then update it. And follow the link to the second observer and update it. And go to the third one and update it, etc. Right? That's how the notify works at the runtime. Yeah. Every subscribe observer will be updated. Of course, if you unsubscribe a particular observer, it will not be updated anymore. Yeah. Okay. So make sure you maintain the runtime links properly. Right? Okay. We just passed the first hour. Any questions? Yeah. You're basically asking something like this. Again, let's say this. Let's say A here, B here, and C here, right? A, B, C. Let's say I got a method here called method AM, I'll just say AM, okay? And then, so this is effective, right? It's implemented, okay? And then over here, I said AM, let me say this. And then I'll say AM plus, that's all I have. Which means this method or feature is first defined in class A, right? And then it was not redefined in class B. So that means class B is gonna inherit AM verbatim, okay? And then what about class C? Yeah, it just redefined by itself. Yeah, redefined, I should say plus plus, okay? Good. So now let's just see some example here. Let's say for AM, we simply just print out, let's say A.AM. For example, that's not something we print out, okay? And for C over here, the redefined version would say C.AM. That's a printout, okay? Let's try some sample code. So let's try the following. Let's say we got, so we got local variable section over here. Let's say A of type A, let me just save it, okay, actually. And B of type A, and C of type A as well, okay? And now let's do some creation. You can say creates A, okay? You can say creates B, create C. Okay, each one of them compile, okay? Now, what I want to know is if I say A.AM, B.AM, and also C.AM, do they all compile or some of them don't compile? All should compile, why? Yeah, AM is in the static type for A, B, and C, right? Okay. So now what you want to say is just sort this out, and then we talk about runtime behavior. So A, B, and C, their static type is just the same, just all to be A, right? And A does have AM defined. So now you're basically asking which version of AM will be called, right? Let's try to sort them out. So we got this, this, and this. Okay, 1, 2, and 3. So what should be printed for 1? So now I'm asking about runtime behavior. That means the dynamic type has to be considered, right? So now, in the case of A, what's the dynamic type? Huh? A, okay, you can see that its dynamic type is A over here, right? Okay, so now that means the version in class A should be called. We do have a version over here, so that's A.AM, okay? Okay, let me change your color here. Now, what about second, B.AM? What's the dynamic type? B? Okay, you can see dynamic type over here, right? So now, which version should be called? Okay, so basically you're asking if the dynamic type is over here, which version should be called? if there's nothing that's redefined over here, we'll define here as for the parent class, right? Indeed, we do have a version here, right? So that means it will just say a.am. Okay, finally, you can see over here, C here, right? Now, dynamic type is C, right? Apparently, right? C is of dynamic type C. Now, which version will be called? C, right? That's dynamic type, that's dynamic binding. In that case, you'll be the redefined version, which is going to print C.am, right? C.am over here. Okay. I think that's what you're asking, right? Okay, good. Yeah, basically, the principle is the same between IFO, Java, or C Sharp, right? So when you want to decide about the runtime behavior, which version would you call? You want to call if the method is not defined in the dynamic type itself, you have to find the closest ancestor that actually defines the method, right? In this case, if the dynamic type is a circle is orange, if dynamic type is over here, all right, the closest method I have, closest class I have is itself. On the other hand, over here, if you see if the dynamic type is B, itself does not define that AM. So we're going to find the closest ancestor, which is over here. That's the closest one. Okay, that's why it's going to call this version here. Yeah. Okay. Right. Yes.
So just to go back to the event.
Sure. Yep. You mean the Java version or IFO version? IFO version, okay. But the idea is really the same, okay? Yeah. If you look at the IFO version, is there a particular slide you want to talk about? Sure. So you can see that in the case of event-driven design, I'll just go over every class very quickly. But remember the arrow I draw in the class, you can review that part of the lecture. Okay. So now, basically, the most important thing for you to define will be the events. So we are saying that every time when you want to do want to subscribe to the events, want to declare the events, you want to give the type for the arguments. So you can think about this argument over here is just a generic parameter. Okay, param, like what we said before, and this arrow here is like extends in Java, which means whatever argument type you pass must be a subclass of tuple. A tuple is simply just a list of different types of objects, right? Can be different types. Okay, and now you can see that as opposed to the case of observer, where you simply got a collection of like observer. Now we don't have that. We simply got a collection of procedure. Procedure is just a class you can reuse in IFO. So it simply means, now if I just go back to the diagram very quickly, the most important thing for you to understand is something called delay execution. Okay? So if you think about it this way, if I got a particular application, I would like to be being notified. What I should do first is that I want to subscribe this particular application to this particular event. That's what I want to do. So what should I give when I do the subscription? So two things. When I do that, first of all, number one, the ID, conceptually the ID or the current object's reference, ID of the application one. And also number two, you want to call for delay execution, which means if I want to update this particular app, when I do the subscription to the event, it's not the time yet to actually update it, right? So there'll be a reference to the updates for delay execution, like a star operator in your 2031 for the C, right? The same idea. So now once I pass these two, and they will be stored in this particular events. So now later on, let's say if there's really an update from the subject side over here, right? So what I should do is I should really say, now for this particular subject, I will go to this particular event. Let's say I will update on the temperature. I'll simply go over all the subscribed operations. So now it's time to execute the action that has been delayed. So now in this case over here, I'll simply just go over every actions in the event and then just execute them. So this is what you will see. Okay? If you look at that over here, Okay, you can see this is just a procedure, which is just like an action, right? Procedure of arguments. So this is reference to updates for delayed execution. Okay, that's what we have, right? And then, so now when you do subscribe, you do publish, what you should do now is, whenever you just add an action, that's easy, just pass a procedure. Procedure like a function to pointer, right? On the other hand, when you want to publish the updates, what you should do now is basically retrieve each action that's stored in this list. And now you want to call that particular action. So action is the item, so this will give you a type procedure. And then make a call on that. So this will give you, and then also give the arguments that you pass over here. Okay, and then you're gonna execute that delay action. Okay, so far so good. Okay, now if you go a little bit, let's just see the other side. Let's say this is the app I'm trying to define over here. How do I subscribe? You can see that over here. I will simply say now I go to the change on temperature. This is an event. Once I get to the events, I will simply say subscribe over here. Now, what do I pass? I will simply pass a pointer to a function. So if I ignore the agents over here, just say update temperature, it will be wrong. Because if you say update temperature, that means execute this feature right away. But I don't want it, right? So what I should do is I simply say agents. So this is a reference for delay execution, right? For delayed execution. Okay, that's what I want to do. Okay, and then that, yeah. So these are the two critical parts for implementing the event-driven design. Yeah. Hey, you okay with that? Good. All right. Okay, next questions. Does that mean you're good? Well, then ask me questions, right? Yeah. Double dispatch? Mean for visitor pattern. What about it?
So let's say we have an example.
Okay, so visitor pattern. So I'll just go back there. Let's say we'll go back to this example here, right? Okay. So now, very briefly about double dispatch. Okay, now for double dispatch, show me something. Okay.
We have to look just how do we.
How do you how the double dispatch happen, or?
Yeah, when we're evaluating it.
Okay. Okay, you're asking about this particular one, so I'll go to visitor again. Okay, so I will go to testing the visitor pattern. Okay, double dispatch over here. I think it's easier. Okay, first of all, let's see how we implement the evaluator over here. Okay, evaluator is a subclass of visitor, right? Now, if you got visit constants and visit addition, right, these are the two possible features for the visitor, right? So now this is, wow, seriously, you have finished the project already, so this should be very easy for you, right? If you haven't, then that means something, right? You haven't really done something properly, right? So now, visit addition over here, so you got simply addition, right? In the case of the addition, we know that you got left and right, right? So that means you have to somehow, a.left is going to give you an expression, right? A.right is also going to give you an expression. So that means you can handle both separately, right? Also recursively. So now when you say a.left.accept and then a.right.accept, it's going to be two different instances of the double dispatch. And then you're going to pass the some visitor objects and some visitor object over here. We just call one is called evaluate left, the other one evaluate right. Okay, now how does double dispatch occur? Okay, so now what I would say is over here, the first dispatch. Dispatch simply means how dynamic binding. Okay, So now, if I look at this line over here, how is the dynamic binding going to occur? What's the type for A left in this case? So over here, yeah, A left, statically, the static type is expression, right? Statically, okay? But in order to decide the first dispatch, sorry, in order to decide the first dispatch, you have to know what's the dynamic type. Of course, you cannot see that from here. It's only the definition for the class, right? Let's see one example, okay? Let's see this one particularly, okay? Let's say if you say addition dot accept, right? In this case, if you try that, so what's the dynamic type for add? Add is over here. What's the dynamic type? Okay, addition, right? Now visitor, right? I'm asking you what's the dynamic type for add, right? You can see that, you can see from here, right? It's addition, right? So that means we're going to say dynamic type for add is addition. And which version of the accept are we going to call? Yeah, exactly. If you go back there, so that means we're going to call visit addition in, we're going to call the accept in the addition class, right? So that will be the first dispatch. That's the first one. And we know that in turn for the accept is going to call v dot visit addition, right? Now, tell me what's v over here? What's v? It's a visitor, I agree, but now dynamically for this particular example, if I just go back there for you, so what's v? No, actually, to be more precise, you can see add the accept, right? Accept is going to take v. What's v here? Expression? Are you sure? No, don't guess. Don't guess. You know. Evaluator. Okay, you can see v was declared over here, and then you can see it's evaluator, right? Okay, so that means when you pass v dynamically, v would be dynamically it's an evaluator. And now in this case, v being dynamically evaluator, now which visit addition are we going to call? Which version? Evaluator, yeah, exactly. So now if we go to evaluator, over there we got visit addition. That means we're going to call this particular one, right? So that's a second dispatch. Okay, that's the first, the two, right? Is it okay? Yeah. Yeah. Yeah, I think, of course, you know, the actual exam question, well, if I do put a visitor pattern there, the actual question may be depending on which test I gave to you, right? Yeah, so you just have to judge to see which what dynamic type it is for the context objects, right? Yeah. Okay, next one. Should we call it a day? Do I have anything else to say? I would say, yeah, study hard. What else can I say? Or I should say you should play some video game. Yeah, you should. What video game? I'm not sure. I don't play video game myself. Yeah, I'm not sure. You know, you can, you know, if you really feel tired, why don't you just relax for a few hours and then study again? Yeah, maybe. Unless you have relaxed since the beginning of the semester. In which case, yeah, I definitely want to study hard. Guys, any questions? Any? You can still come tomorrow. You're still welcome to come. I suspect maybe tomorrow will be more people coming. Yes?
So, you mentioned the observer pattern goes just across things.
Observer pattern, I mean the across, notify? Oh, I see. Okay, you're basically asking the following. Let me just go back to observer. So, okay, let me go to observer. You're basically asking, okay, let me just go to the link over here. Basically, I would say observer is pretty reasonable pattern, right? It's still not very easy to implement. You got to understand polymorphism very thoroughly. So this is the runtime structure for observer pattern, right? So the drawback is when you got at the runtime so many subjects over here and also so many observer over here, the runtime links between all the multiple subjects and multiple observers will be quite complicated, right? We know that complexity is simply n multiplied by n, right? That's something we said. So this is maybe not so good in a large scale system, right? If you want to reduce the complexity, what we recommend is you try the event-driven design over here that can reduce into n plus n, right? That's basically the design decision you have to make. Of course, the syntax support in the language you program in will be very important. Okay? In the case of Java, you have to find a way to actually pass reference to methods. In the case of IFO, they do have some native support. Let's say if you try to program in C#, they got something called delegates. You can also do that event-driven design rather quickly, easily. For Python, I'm not too sure. You can check. Right? Yeah. Anything else? Yeah? You mean to extend the time? Well, I would start with 2 hours. You know, if everybody's, well, it depends on how many people show up, right? Yeah. You're gonna be, yes, yeah, we'll see how many people show up tomorrow. We'll see, yeah, let's see. Guys, anything else? Or should we let you go? Okay, sounds good.